Look at this. A galaxy. 400 billion stars, trillions of miles of gas and dust, spinning through space for over 10 billion years. And it's flat. Not round like a ball, flat, like somebody rolled it out. Now, here's the part that should bother you. Gravity pulls things toward each other from every direction, equally. So if you dump a billion stars into space and let gravity do its thing, physics says you should get a ball, a sphere, not a plate. So why does almost every big galaxy in the universe, including the one you're sitting in right now, look like a pancake instead of a beach ball? Here's what makes this genuinely strange. Small clusters of stars, called globular clusters, maybe a few 100,000 stars, they do form neat little spheres, exactly like gravity textbooks would predict. But scale that up to hundreds of billions of stars, add gas and dust into the mix, and suddenly the shape completely changes. It stops being a ball and becomes a plate with a bulge in the middle, like a fried egg the size of a galaxy. That's our galaxy, by the way, the Milky Way. Every star you've ever seen in the night sky, including our sun, is basically riding on a flat plane, like a marble rolling around on a dinner plate the size of 100,000 light years. So what turns a ball of gravity into a plate? The answer starts with something spinning in your kitchen sink. Every galaxy starts life as a giant, slow-moving cloud of gas, mostly hydrogen, spread out over trillions of miles. And here's the key detail almost nobody thinks about. That cloud is never perfectly still. It always has a tiny, tiny bit of overall spin to it. Some clumps happen to be moving slightly clockwise, some slightly counterclockwise, and when you add it all up, it never cancels out to exactly zero. There's always a leftover net spin in some direction. Now gravity starts pulling this cloud inward, collapsing it down, and this is where the ice skater trick kicks in. Just like a skater spins faster when she pulls her arms in, the collapsing cloud spins faster and faster as it shrinks because of something physicists call the conservation of angular momentum. Spin can't just disappear. As the cloud gets smaller, that spin has to concentrate, so the whole thing speeds up. And once something is spinning fast enough, it starts fighting back against gravity, but only in one direction. That's the part that changes everything. Picture spinning a ball of pizza dough on your fist. As you spin it faster, it doesn't stay a ball, it flattens into a disc. Why? Because spinning creates an outward pushing effect, but only in the plane of the spin. Straight up and down, along the spinning axis, there's nothing pushing back. Gravity just pulls freely. Same exact thing happens to a galaxy-sized gas cloud. Around its spinning equator, the rotation creates enough outward force to balance gravity, so it can't collapse any further in that direction. But up and down, above and below the spin, there's no spin to resist gravity there, so gravity just keeps winning, pulling material down into a thinner and thinner sheet. Round ball in, flat disk out. That's step one, but there's a second ingredient, and it's the one that actually seals the deal. Gas isn't like stars. Stars almost never crash into each other. Space is too empty and stars are too small compared to the distances between them. But gas clouds are huge, messy, and they do collide with each other constantly, like invisible clumps of fog crashing through one another. Every time two clumps of gas moving in different directions collide, they lose energy. That energy turns into heat, and the heat radiates away into space as light. It's gone forever. But clumps of gas that happen to be moving in the same direction, in that same flat spinning plane, they don't collide nearly as much because they're all moving together, like cars on the same racetrack instead of bumper cars. So that motion survives. It doesn't get canceled out. So here's what actually happens, put together. Any motion that fights the rotation gets destroyed through collisions and radiated away as heat. Any motion that goes with the rotation survives. Repeat that a few million times, and every random chaotic direction gets erased except one, the disk. That's not a coincidence. That's the only shape left standing after everything else cancels itself out. Okay, but here's the twist almost nobody tells you. Not every galaxy is flat. About a third of the big galaxies out there are what astronomers call ellipticals, and they're not plates. They're puffy 3D blobs, almost like a football or rugby ball, with stars zooming around in every random direction imaginable, up, down, sideways, all at once. Why the difference? Two reasons. First, ellipticals are usually almost completely out of gas. They used it all up billions of years ago or lost it in collisions. And remember, gas is what does the actual flattening through all those collisions we just talked about. Stars don't crash into each other, so once a galaxy is just stars, there's nothing left to flatten it. Second, and this is the wild part, many ellipticals are actually the wreckage of two flat spinning disk galaxies that smashed into each other. When two spinning disks collide, their neat, orderly orbits get completely scrambled, like shuffling two decks of cards together. All that careful flattening gets undone in one galactic collision. So the real answer isn't gravity makes flat disks. The real answer is spin plus colliding gas makes flat disks. Take away either ingredient and you get a blob instead. And once you see this pattern, you start noticing it everywhere. Saturn's rings, same physics, colliding ice chunks flattening into a plane. The disk of gas and dust that planets are born from around baby stars, same physics. Even our own solar system, every planet orbiting the sun on almost exactly the same flat plane, same physics, just on a smaller scale, billions of years ago. Spin something, let it collide with itself, wait. It doesn't matter if it's a gas cloud, a ring of ice, or pizza dough, physics keeps landing on the same shape over and over at every size in the universe. From a pizza spinning in a kitchen in New York to a spinning cloud of gas 13 billion years ago that became your entire galaxy. So next time you look up at the night sky, remember, you're not just standing on a planet. You're standing on a flat plate of stars spinning through space that only exists because billions of years ago, a messy cloud of gas couldn't stop colliding with itself. But here's a question worth sitting with. Our own solar system formed the exact same way, flattening out from a spinning disk of dust. So what happens when our galaxy eventually collides with the next one over, Andromeda, in about 4 billion years? Drop your guess in the comments, and if this kind of "wait, why does that happen?" question lives in your head, like, share, and subscribe, because that's exactly what this channel is built on.